Hey everyone, today we're going to be talking about composite functions. So composite functions are basically any two given functions and you're asked to find the composite of them. So let's say we're given two functions, f of x equals 3x squared plus 5 and g of x equals 2x squared plus 3. And when we're doing composite functions in algebra, you're most likely going to be asked one of these here at the bottom. So you're going to be asked f of g of x, g of f of x, f of x, etc. So it could also be g of x and so forth. But this can also be represented by this notation over here, where you kind of have f and then kind of like a little circle of g of x. So you're basically saying f of g of x and g of f of x. So we're going to be doing some examples and I'm going to be showing you how to actually solve these composite functions. Okay, so here we have our first example. We have f of x equals x plus 3 and g of x equals x plus 5. And now we have two different questions. So one of them is f of g of x and one of them is g of f of x. As I said before, this would be the same notation as g of f of x. And this would be the same notation as, f of g of x. So if you're seeing these two different notations, don't worry, they all mean the same thing, just composite functions. So let's do the first question, which is f of g of x. So basically what we're going to be doing is substituting g of x in the function f, if that makes sense. So let's take g of x, which is x plus 5, and let's substitute that in place of f of x. So we're basically going to substitute f of x plus 5. And if you know how to work with functions, you know that if you include x plus 5 in these brackets, you're basically, what you're doing is you're replacing the x value in the initial function with this value here in brackets, so x plus 5. So instead of x, if we write x plus 5, and we're going to bring the 3 down as well, we're just going to have x plus 5 plus 3, which is x plus 8, which is going to be our final answer for f of g of x. Now let's do the same thing for g of f of x over here. In this case, all we're going to be doing is substituting f of x into the function g. So f of x is x plus 3. And now we're just going to substitute x plus 3 in the function g. And if, again, as in our last example, it's going to be the same thing. Instead of this x value, we're going to replace x plus 3. So it's going to be x plus 3. And then we're going to bring this 5 down here too, so plus 5. So it's equal to x plus 8. And as you can see, both the inverses, or the composite functions, are the same. So here we have two different functions, f of x equals 2x squared plus 5, and g of x equals x plus 3. So this is going to be pretty similar to our last example in that we're just going to substitute each equation. So our first question here is f of g of x. So you're just going to be substituting g of x in the function f. So let's take the equation g of x. So g of x is equal to x plus 3. Now you're going to substitute this entire x plus 3 into the function f. So it's just technically f of x plus 3. And if you do functions, or if you're familiar with functions, you'll know that substituting this is basically just replacing the x value of the function. So we're going to replace this x over here with x plus 3. So if we write that over here, we're going to get 2 times, we're going to write x plus 3 instead of the x. We're going to leave it to the squared because this x over here is squared as well. And we're going to add that 5 here. So this would be f of x plus 3, and now we're just going to simplify. First, we're going to expand. If you expand x plus 3 the whole square, you'll get x squared plus 6x plus 9, and we'll write that 5 again. And now we're going to expand again, so 2x squared plus 12x plus 18. What I did now was I just multiplied the 2 by each term on the inside. And then you're going to leave that 5, and your final answer would be 2x squared plus 12x plus 23. So this is your final answer for this composite function, and let's move on to the next example. So over here on the right, we have g of x. So basically what we're going to be doing is just taking the function g of x and substituting it again into the function g. It's pretty simple, so you're just going to find g of x plus 3, because x plus 3 is the function g. So now we're just going to replace it instead of x. So we're going to write x plus 3, and we're going to bring that plus 3 because we're only replacing the x. This will simplify to x plus 6. So this would be your final answer for the composite function g of x.